Okay, so we're going to go over section 3.2, which is relations and functions. And today we're going to look at how to decide if a relation is a function, and we're going to look at domain and range, okay? So domain always refers to your x values, range always refers to your y values. Okay, so we're going to look at drawing tables of values, graphing tables of values, and drawing mapping diagrams. Okay, so that's the first part of our lesson. So if we look at example 1, we have the points 1, 5, 2, 3, 3, 2, and 4, 1. Okay. And we are going to put these into a table, into a graph, and into a mapping diagram. Okay? Okay, the first values in your set are always referring to your x values. Okay, so your first numbers are always your x's. So in this case, our x's are 1, 2, 3, and 4. Your second values are always your y values. So y, 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 y. So 5, 3, 2, and 1. Perfect. Okay. When we graph those, this is your x-axis, this is your y-axis, so we're going to graph them going on our x-axis first. Your x-axis tells you how much to the left or right you go, and your y-axis tells you how much up or down you go. So positive 1 tells us to go over 1, and then positive 5 tells us to go up 5. So my first point is over 1, up 5. Second point then would be over 2, up 3, over 3, up 2, and over 4, up 1. So if you plot those points, you get something that looks kind of like that. And then the last thing we're going to do is a map. Yep. So our mapping diagram looks just like our table, so we copy our values down from our table onto our mapping diagram. And then we map our numbers to each other. So we notice that 1 goes with 5, 2 goes with 3, 3 goes with 2, and 4 goes with 1. And we make mapping diagrams because it helps us tell whether or not it's a function. Okay? So if we do that again with the points 1, 3, 2, 4, and 3, 5, what are going to be my x values? 1, 2, and 3, perfect. And what are going to be my y values? 3, 4, and 5. Okay? So my x's and my y's. Then if I graph, I go over 1, up 3, over 2, up 4, over 3, up 5. The last thing I'm going to do is do my map. So x, y. So 1, 2 is 3 again, and 3, 4, and 5 again. And we just map them. 1 connects to 3, 2 connects to 4, and 3 connects to 5. Okay. The next thing we're going to look at is domain and range. And remember that I told you that your domain refers to your x values, and your range refers to your y values. And we always put domain and range in curly brackets. Okay? So in this case, my x value is 1, and my y and my other x value is 3. So my domain would be 1 and 3. And my range values are my y values. So my y value is 2 and 4. So 2 and 4. It's kind of like a horizontal table. Okay? So your table is going to be vertical. This is like your horizontal table. Okay, so let's do that again. So I'm given this mapping diagram. So what are my domain values? My x values. 6, 5, 2, and 1. Okay, and what are my range values, my y values? Perfect, -4, -1, and 0. This one asks for domain and range, that's all it's asking for. The last thing that we're going to look at is a function, which is a special type of relation in which each domain value has exactly one range value, okay? So we sometimes say it has one x for one y, or we can just shorten that to say it's a one-to-one function. Okay, so that's what that means when it's a function. It's having 1x equals 1y. Okay, so if we look at example 3a, we're given these x values and these y values, and we're going to put them into a map so that we can decide if it is a function. Okay, so my x values go over here, so 75, 68, and 125. Then my y values are 2, 2, and 3, and I don't write the 2 twice because that'd be redundant. So my y values are just 2 and 3, and then I draw arrows to map them. So 75 is connected to 2, 68 is also connected to 2, and 125 is connected to 3. And the only part of my map that I care about when I'm deciding if it's a function is my x part. Okay? I don't care about my y part when deciding if it's a function. So if I look at my x values, I have to count the number of arrows that come out of these. So there's one arrow that comes out of 75, one arrow that comes out of 68, and one arrow that comes out of 125. If there's only one arrow, then it's a function. If there's 2 or more arrows, then it's not a function. So this one's a function because there's only one coming out of each of those. But if we look at, like this example, where we have 7, 9, 12, and 15, and -7, -1, and 0, it's already in a map, so we don't have to worry about mapping it. So we're just going to look at just my x values. Are there any x values that have more than one arrow coming out of them? 7, exactly. 7 has 2 arrows coming out of it. So since 7 has 2 arrows coming out of it, this is not a function. So remember, one arrow means function. 2 or more means not a function. Okay? The other way to tell if something is a function is by doing the vertical line test, which is what you guys are going to quiz on Wednesday, okay? So you're quizzing on Wednesday on the vertical line test. And for the vertical line test, all we do is we pick any point on our circle, and we draw a vertical line, any point on our graph. Okay? And then we count the number of times that it crosses. So how many times did it cross our graph? Twice, right? Okay. So this is not a function because it crossed more than once. To be a function, just like with arrows, it can only have it once because it's a 1x to 1y. So this is not a function because there's 2 of them, 2 spots that cross. Okay, so let's look at this line graph. I can draw a line anywhere, so I'm going to draw it way down here. Okay, how many times does it cross? Once. So is it a function or not a function? A function, because it only crosses once. If it only crosses once, it's a function. If it crosses more than once, it's not a function. Okay, and that's what you guys are going to quiz on Wednesday. Okay? So you guys are going to work on page 173, 1 through 20.